All right, this video is going to cover 3 different theorems about chords in a circle. First thing we need to review is that a chord is a segment and both of its endpoints are going to be on this circle. So what we're going to go ahead and start off with here is we're going to have 2 minor arcs are going to be congruent if and only if their corresponding chords are congruent. So if we draw in 2 chords here, let's say chord AB, and down here we'll go ahead and draw in chord CD. We're stating here, now we need to remember about our biconditionals if and only if this states that the conditional statement and its converse are true, meaning it's going to go both directions here. So if we have 2 minor arcs that are congruent, the corresponding chords will be congruent, and vice versa. If 2 chords are congruent, then their corresponding arcs will be congruent. So what that means here, if we have minor arc AB and minor arc CD congruent, then those chords will be congruent as well. So problems 1 and 2 are going to cover this information. So number 1 says that if the measure of arc AB is 78 in this embroidery hoop, we're going to find the measurement of arc CD. So we're seeing here that the 2 chords are going to be congruent. That means our arcs are congruent. So here, since the measure of arc CD will be congruent to the measure of arc AB, and AB was 78, therefore the measure of arc CD is also 78. Short, sweet, and simple like that. Number 2, we're going to go ahead and bring in some algebra. In circle W, arc RS right here is going to be congruent to arc TV, and they went ahead and put those markings. So what we're going to do is we're going to find the length of the chord RS. So after we solve for x, we need to substitute back in for 5x minus 9. The 5x minus 9 will go to chord RS. The 2x plus 3 will go to chord TV. So we'll go ahead, and since they are congruent, because their corresponding arcs are congruent, we'll go ahead and set them equal to each other. 5x minus 9 is equal to 2x plus 3. We'll go ahead and solve. Move our variables to one side. And then move our constants to the other side. We divide, and we're going to find out that x is going to be equal to 4. So now we need to plug in for RS. RS was 5x minus 9. We're going to remove x, and we're going to substitute in that 4. When we do all the math, RS is going to equal 11. The next theorem we're going to talk about is a diameter is perpendicular to a chord if and only if the diameter bisects the chord. So if we have diameter crossing through a chord, it's going to be perpendicular if it bisects, as well as if we see that a diameter is bisecting a chord, we automatically know it's perpendicular. So here we'll go ahead and draw in a diameter. And then we'll draw in a chord. And what we're going to see here is we're going to mark the chord bisected, showing us that we're going to have this right angle. So with number 3, we're going to solve for x. We are seeing that we have a diameter in a chord and it's perpendicular. So we automatically know the chord is bisected. So x is simply going to equal 5. For number 4, we're going to find AB. So this is going to be another substitute in. AB is going to be the entire thing. So we have to substitute in for the x plus 6 and 2x minus 20 and add them together. So let's first start off by solving. We're going to set these equal because they are congruent. So we have our x plus 6 equal to 2x minus 20. Just like we did on problem number 2, let's move our variables to one side. 6 equals x minus 20. And then we're going to add that 20 to get x by itself. So x will equal 26. Now when we substitute back in, we need to remember that AB is going to be both these pieces together. So it would be the x plus 6 plus the 2x minus 20. I'm just going to go ahead and do this, combine my like terms, and then plug in. So we wind up with 3x minus 14. That's what this entire chord is. We're going to remove x and substitute in with that 26. And when we do the calculations, we're going to find that AB is going to be 64. The next two problems, let's take a look. We're going to change it up a little bit here. Number 5, we're going to have to draw our circle on our own. So we're going to go ahead and draw in our circle. This is going to be, we're going to talk about the diameter of circle with center P. So the center of the circle, point P. Let's go ahead and draw in our diameter. It's going to bisect segment AB. So let's go ahead and draw in segment AB. And it's going to bisect it at point X, meaning right here, this will be X. And segment AB has been bisected, so segment AX is congruent to segment XB. We're going to, points A and B will lie on the circle telling us that we have a chord. We're going to classify this the triangle formed by points A, X, and P. So we need to draw in the triangle. And because the diameter bisects chord, the segment AB, according to our theorem, they will be perpendicular. So when we draw on that 90-degree angle, we're seeing here that this triangle formed by points A, X, and P is a right triangle. We're going to use this to help us with number 6. We're told that the distance between a 16-foot long chord, so AB right here is going to be 16 feet. Now we do see that it has been bisected, so what we're going to end up using here is we want to make sure that we see that each part of the chord is 8 feet, and the center of the circle is 15 feet. So right here we've got 15. We're going to label the figure, which we already did, accordingly, and we're going to find DE and the diameter. So we want to make sure finding both of these. So I've written down a couple things here. What we're going to do is to find DE and the diameter. We know that from D to C right here is going to be 15. What we're going to do here is go ahead and draw in the segment from D to B like we did over here on number 5 so we can create our right triangle. And so what we're seeing here is that segment DE, the entire thing, the 15 plus whatever this is right here, is going to be a radius. That's what we're looking for. If we draw in segment DB, this is also a radius because it goes from the center to the circle. So we're going to create this right triangle. We're going to use Pythagorean theorem using that segment CD is 15 and segment CB is 8. Once we find the measurement of this hypotenuse, segment DB, it's going to be the radius, therefore DE will be a radius, and that will solve for DE. Then we just double it for the diameter. So let's go ahead and set up our Pythagorean theorem. Using this triangle here, we'll have 8 squared plus 15 squared equals C squared, which will be DB. We get 64 plus 225. When we add those together, we get 289. When we take the square root, this is a perfect square, so we will get a whole number of 17. So right here, DB is going to be 17. So if DB is 17, DE is also 17 because, again, up here we wrote that they are both a radius. Now to find the diameter, we just need to take DE and we need to multiply it by 2. And we're going to get 34 feet. A lot of stuff involved with that. Please go back and watch it again if you need to. The last theorem that we're going to talk about is that if we have two chords are congruent if and only if they are equidistant from the center of the circle. And again, vice versa. If two chords are equidistant from the center, then they are congruent. So here we're going to say if, let's go ahead and draw in a couple chords, and let's just go ahead and state these two chords are congruent. So if these two chords are congruent, then, let's go ahead and draw those two chords back in again, then these two congruent chords are going to be equidistant from that center. We'll go ahead and draw 90 degrees because these will have 90 degrees here. Oops, sorry, not there. Over here. A little sloppy, but you can see in the diagrams down on number 7 and 8 what they should kind of look like. So here we're being told that the length of AB is equal to the length of CD. So these two chords will be congruent, meaning they will be equidistant from the center. So we just set these equal to each other, and they're only asking for us to find x, so we don't have to substitute anything in. So we'll subtract that 6 from both sides, getting us 2x equals 18. And then we divide by 2, x will equal 9. We're going to have the exact same thing on number 8, but instead of saying that the chords are congruent, they're going to tell us that the chords are equidistant. So see how they've changed that up. Now we're saying these are equidistant, therefore we're going the other direction. Our chords are congruent. So we set 6x minus 7 equal to 35. They're only asking for x. So we just have 2 steps here to solve. Add 7 to both sides. We're going to get 6x equals 42. Then we divide both sides by the 6, and we get x will equal 7.